Hello everyone. We are going to discuss today the topic called motion under gravity. So while we are discussing this topic, there is a one term is coming, the gravity. As you already know what is meant by gravity, right? If you throw an object upward, what will happen to the ball actually? Ball will come downward. If I release an object, what is actually happened to the ball? The ball is coming downward. That means in these cases, the ball will definitely will come downward. That is due to what? Earth gravity. That means the earth is pulling each and every object towards its center. So this is the main thing we are going to deal here. So the first example you should consider here, an object is projecting upward. Another case we are going to deal with here, an object is releasing. From rest. So in this example, this is coming under a uniformly accelerated motion. What is that? Uniformly accelerated motion. In both the case, the motion of the ball, what is the acceleration? The acceleration is equal to acceleration due to gravity. What is acceleration due to gravity? G is equal to 9.8 meter per second square, or approximately we can consider as 10 meter per second square. So these are the cases now we are going to deal here. So the first case, when the ball is throwing upward. So when the ball is throwing upward, I should give an initial velocity as the projection velocity, right? That is a u, you can take it if it is projecting upward. While it is going upward, you can see at one particular point it will stop. In a fraction of a second it may stop. After that it will again come down. So while the ball is going upward, what is actually happening there? The velocity keep on decreasing and finally it come to zero. Correct? That means this is the motion shows what? Decreasing velocity. At the same time, acceleration is same only, that is a g value will be acting vertically downward. Vertically downward. Next one, it is reached here at the top and again coming downward. At the top, what is the velocity? Is equal to 0. While it is coming downward, what is actually happened to the velocity? Velocity keep on increasing. So this motion shows what? Increasing velocity. But the motion is what? Uniformly accelerated motion. Here also what is acceleration? Acceleration is the acceleration due to gravity, g value itself. So this is the one we are going to deal here, the motion under gravity, or we can also say that the vertical motion under gravity, g value. Okay. Now, we have already discussed about the equations of motion for uniformly accelerated motion. What are the equations? V is equal to u plus at. Same way, S is equal to ut plus half at square, right? Third one, V square is equal to u square plus 2as, right? One more equation we have learned about the distance traveled in nth second. So we have written that equation as xn. I am writing here Sn. Snth is equal to what? U plus a by 2 into 2n minus 1. So these are the equations of motion we have discussed for a uniformly accelerated motion. Now the same equations of motion, uniformly accelerated motion, is coming in the vertical motion under gravity. What will happen there? All the acceleration term become what? G value. Now for the sign convention, we are using, see this one, when you are throwing upward or while it is releasing, always the g is acting vertically downward. So we are taking always the g is negative. So what is the sign convention? We are taking the g value is always negative. So what is the equations of motion become? The equations of motion in vertical motion become V is equal to, see this one, V is equal to U minus GT. V is equal to U minus GT. Now instead of S, it's a vertical motion, right? So I'm marking it as H, the height of the vertical motion. H is equal to ut minus half gt square. Third one, v square is equal to u square minus 2gh. Instead of s, once again we are using what? H. The last equation, s nth second, or we can say it as hn, right? hn is equal to what? U minus g by 2 into 2n minus 1. So these are the equations of motion for a uniformly accelerated vertical motion. That is, while we are using the acceleration, instead of acceleration, we are using here what? Acceleration due to gravity. So both these side equations represents what? A uniformly accelerated motion. Correct? And this also we have explained for what? Motion in a straight line as a one-dimensional motion. In the case of one-dimensional motion. So this is also one-dimensional motion because ball is going upward and ball is coming downward. This is what? Vertical motion. Only one axis values is changing. So this is also using for what? One-dimensional motion. So in order to do the numericals in motion under gravity, we need to know some sign conventions. So what are the sign conventions we are basically using here? First case, for using sign convention, we are using the rectangular coordinate system. As you already know what is meant by rectangular coordinate system, x-axis, y-axis, z-axis. Now in this case, the motion under gravity, there is only one axis we are using. Say it as y-axis because it's a vertical motion. Okay, so rectangular coordinate system we are using for the sign convention. Now, upward direction can be taken as positive. The second sign convention, the upward direction can be taken as positive. So for example, if I am throwing upward direction is taken as positive. So all the physical quantities which is coming in that direction can be taken as what? Positive. Correct? In the opposite direction it can be taken as what? Negative. Next point is that while you are considering this type of problem, we have to consider or we have to choose one origin. So origin we can take anywhere, maybe at the ground, the projection from the ground, or you can take any point as origin. That depends upon our convenience. So we can take it as above the origin can be taken as positive and below the origin can be taken as negative. The next point is that, as I already mentioned here, g value we are considering always negative quantity because as you already know, it is always acting vertically downward towards the earth center. Next one is that time quantity. Time we can never take it as a negative in this case. So time is always taken as what? Positive. As a sign convention, time in this case we are taken as what? Positive quantity. So these are the sign conventions mainly we require to do or to solve the numericals from motion under gravity. Now let's discuss some important relation to do some problems. Consider a body is projected upward. Just imagine this is the ground. A body is now projected upward. It will go upward and definitely it will come downward also due to gravity. While the ball is now projecting, definitely you must give an initial velocity u, right? So this must be high value. And when it is going upward direction, what will happen to the velocity? At this point, the velocity become 0. At that particular point, velocity become 0. Now, while it is coming downward, say it as this is the other side of this motion. Say we can say that u is equal to 0. While it is coming downward, I can take as here what initial velocity is u, which is equal to 0. When it is coming downward and just before hitting the ground, what will happen to the velocity? You see this one? Velocity, what will happen? The velocity will be maximum. So we are writing it as what? Velocity v. Final velocity is equal to what? V. So what is the first equation what we require here? What is the time taken to reach at the highest point? That is called time of ascent. What is that? Time of ascent. Now, what is the time taken to reach the ball or the object to the ground? That is called time of descent. Marking it as time of descent, D. So, ascent and descent. So, just calculate what is the time. So, you can use any equations of motion here. Let's use in the first case, V is equal to U minus GT. V is equal to U minus GT while the ball is going upward. And that time we have taken as ascending time, time of ascent. Here V is equal to what? When it is going upward till reach the point, highest point, 0. 0 is equal to U minus GTA. Same way we can write, if you rearrange this formula, U is equal to GTA. Or we can say that the time of ascent TA is equal to what? U divided by G. So this is the first relation is required what? Time of ascent. What is that? Time of ascent. While you are taking downward direction, what is the time? That is we have denoted as what? Time of descent. So let's see this one. Time of ascent is equal to U by G. So in this type of motion, we can always say that time of ascent is equal to time of descent. What is the meaning here? If I am projecting a ball upward, the time taken to reach the ball at the highest point is same as the ball will come from highest point to the lowest point. That time will be what? Equal. But all this case we are considering that there is no air resistance at all. That means we are imagining that all these processes are taking place in what? In vacuum. There is no air resistance. So in this type of problem we are not considering what? Air resistance. Next equation what we have to require here. While it is coming downward or while you are projecting upward, you require a velocity. While you are projecting upward, that velocity is called U here, and while it is coming downward we have marked here velocity V. You can denote it in any other letter. In this case, if the air resistance is not considering, the U, the projection velocity U and the reaching velocity V will be always constant if you are not considering the air resistance. That means I am projecting this ball from this point with an initial velocity of 20 meter per second. The ball will go up, the velocity will decrease now, decrease 20, become 10 and finally come to 0. Again it will slowly increases 10, 20, 30, etc. Correct? Now in this case, while the body is projected from this point, if it is 30 meter per second, while the body is coming and crossing this point, at the velocity also become what? 30 meter per second. So initial velocity U and here at this point of projection U and exactly at the point just before hitting the ground, the velocity become what? Equal. Is that clear? That is the next point we should consider here. Another case, look at the second case in this case. Ball is coming downward. Here when the ball is coming downward, we have marked here U is equal to 0. If so, what is the final velocity? We can use the equations of motion. V square is equal to U square minus 2gh. H is the height of this motion. H is the height. So V square is equal to U square minus 2gh. Here what is the U value? 0. Here U value is equal to 0. Now if you use this one, downward direction can be taken as, H can be taken as negative, right? So we formula become what? V square is equal to 2gh, or what is the V become? V is equal to root of 2gh. This is another formula required in this type of problem. V is equal to root 2gh means the projection velocity is also same now. So we can write what? U is equal to root 2gh. Correct? Now, what is the time of ascent formula or time of descent formula? Both are equal, right? So time of ascent is equal to time of descent, which is equal to U divided by G. U divided by G. U as well as this V, exactly at the point of projection and reaching at the same point, u and v are equal. So we can substitute for v here in this case. So time of ascent as well as time of descent is equal to, what is the formula become? Root of 2gh divided by g. That is, time of ascent as well as time of descent can be written as root of 2, you see this one, if you take the g into the root, it becomes g square, right? So we can write what? G cancel. So we can write here 2h divided by g. 2h divided by g. Just to take this g into the square root. So g become g square. So 1g and 1g will cancel and the final equation become what? 2h by g. So we have discussed two formulas here. One is initial velocity as well as final velocity is equal to root 2gh. Next one is time of ascent as well as time of descent is equal to what? U by g. Or also can be written as what? Root of 2h by g. This same equation will come when an object is now falling freely. When an object is falling freely, the same equation will come here. So, and this type of motion is coming under what? Free fall. What is meant by free fall? An object is freely falling under gravity without air resistance. In that case also, the time taken to reach here, the formula become what? Root of 2h by g. So here we have discussed three cases. What is first case here? The point of projection, the velocity was u. When the body will go up and come down and exactly reach at the same point, the velocities are what? Equal. Next one we have proved the point here what? Time of ascent and time of descent will be equal. Now we have discussed other formula, time of ascent as well as time of descent formula is equal to what? U by g or v by g. U and v are equal. Now we have discussed about the formula for final velocity as well as the projection velocity. U is equal to what? Root of 2gh, where h is the height and g is the acceleration due to gravity. Okay, so these are the formula we have just now discussed. Consider a ball is falling freely. Okay, an object is falling freely. What is the height or distance traveled in nth second? So we have already discussed that formula. H nth is equal to u minus g by 2 into 2n minus 1. 2n minus 1. If you use the sign convention, h also taken as negative. And what is the u value? While it is dropping an object, it is 0. While you are dropping an object, what is the initial velocity? 0. And h is also minus, so minus minus cancel. So we can write the formula h nth is equal to g by 2 into 2n minus 1. Here g by 2 is a constant value. So we can write this equation as h nth is directly proportional to 2n minus 1. Here what is n represents? N represents the time. Maybe first second, now second second, third second, fourth second, etc. Right? Just imagine where n is equal to 1, 2, 3, 4, etc. It's a time actually. Imagine n equal to 1. So I am writing here h1. h1 is directly proportional to what will come now here? 2 into 1 minus 1. That is equal to 1. Okay. If I am substituting for n2, I can write here h2 is directly proportional to 2 into 2, 4. 4 minus 1 what? 3. I can write like this. Once again, if I write the third second, the height or the distance traveled in third second, h3 is directly proportional to, if it is 3, 2 into 3 what? 6, 6 minus 1 what? 5. So if I am writing the ratio of the height traveled by the falling body, h1 is to h2 is to h3 is to etc. is equal to 1 is to 3 is to 5 is to etc. That means all the odd numbers will come here. So this is coming in another topic called Galileo's law of odd numbers. So this is one of the conclusion here. H nth second, what is the ratio of the height traveled in the first second, second second, third second, fourth second, etc. The topics what we have discussed today. So mainly we are dealing with what? motion under gravity, that is accelerated, uniformly accelerated motion, where g value is taken as 9.8 meter per second square, or approximately 10 meter per second square. Okay, so the remaining section will be discussed in the next classes. Okay, I hope it is understood. Okay, thank you all of you.